Greetings, ladies and gentlemen, and welcome to unit number 9. And here we're going to begin with some more geometry, this time surface area and volume. So we are going to be dealing with three-dimensional figures. And I apologize for having 3 videos tonight. It is what it is. And this first one and the second one and the third one, they're going to be a tiny bit longer tonight. But that's why I broke it into 3. So hopefully they won't be too long. But it's very important that we learn to identify and understand what a prism is and the parts of it. You see, ladies and gentlemen, we're going to use all the math that we've already learned how to do. We're going to use literal equations. Literal equations are formulas, and these formulas will help us find surface area and volume of different shapes, different prisms, or cylinders, or pyramids. And we have to recognize and identify the parts of these prisms so that we can then substitute those values, those measurements for the values that are represented by these letters in the equation. We're going to substitute those values into the equation, and then it's nothing more than using order of operations. One of our first lessons ever this year, we're going to use order of operations to solve and find a value in this equation. So ladies and gentlemen, we're going to use the formula to find the surface area of prism. So we're going to concentrate on surface area today. Our essential question: what is a prism and how do you find its surface area? Ladies and gentlemen, so important to pay attention. You were asked to take notes on the surface area of rectangular prisms at the top of page 356. Now, I gave you that entire front page, and that is because I'm hoping that in this video, which is going to be entirely on what a rectangular prism is, and these notes, I'm hoping that you will add something from this video into those notes. All right? So first of all, let's talk about a rectangular prism. A rectangular prism is identified because of the shape of its base. So a rectangular prism has bases. Those bases are opposite sides, which are parallel and congruent. So important. Every single prism has one pair of opposite sides that are parallel and congruent, meaning they're the same exact size. Of course, the first one we're going to start with has more than one, but we'll get into that in a minute. And understand that the name of the prism, the name of the prism is always related to the shape of the base. So in other words, if we're talking about a rectangular prism, then what is the shape of the bases? Because there's at least 2 of them, and they're opposite, they're parallel, and they're congruent. They must be rectangles in this particular case. And please understand, all squares are rectangles. So we wouldn't call it a square prism. We do have a special name for a square prism, and that would be a cube, where all the sides are exactly the same size because every single one of them is a square and they're all the same. And we're going to talk about rectangular prisms. So we have these bases. Now, ladies and gentlemen, this picture from your book doesn't quite do justice. So you can see the red at the top. That is a base. Its opposite side would be at the bottom. So this bottom one needs to be shaded red as well, because those are the bases. They are opposite, they are parallel, and they are congruent. They are the bases. That's why I put a capital B on them, because they are 2-dimensional. We've used B's and called bases before on 2-dimensional figures as for a side length. But now I'm talking about the entire 2-dimensional part and not just a length. I'm talking about that this is a shape that is a base. And I'm going to call this the top, and I'm going to call this one the bottom. Okay? And then, additionally, we have lateral faces. Lateral faces are all the other sides to the prism, and they could be some other shape. Mostly in a prism, they are going to be some form of rectangle if it is a prism. Okay? But in this particular case, this rectangular prism has 4 lateral faces. We have the sides, and the sides, one side here and one side over there, those are the lateral faces. Now, I told you that in this particular case, this rectangular prism, it is an interesting beast because these sides in a rectangular prism, they're also opposite, they're also parallel, And they are also congruent. So technically, if I wanted to identify the sides as the bases, I could. Most people are comfortable with the top and the bottom being the bases. And then lastly, we have the front and the back, which are also lateral faces. So we have the front here, and we have the back, which again is a B. We have a back, so we have the top, the bottom, the side, the front, and the back. We have 6. We have 2 bases, that's the top and the bottom. And then we have the 4 lateral faces, the 2 sides, and the front and the back. Ladies and gentlemen, the height of this prism, which is extremely important. The height is the distance. It is the distance. It is the distance. I'm going to use a green H. It is the distance between the bases. So no matter where you call the bases on a rectangular prism, the distance between those bases, the distance between the 2 opposite, parallel, congruent sides is called the height of that prism. Let's look at something we call a net. In other words, if I take this box, this rectangular prism, and I unfold it, I would have a net. A net is a 2-dimensional drawing of a 3-dimensional figure. So right now, it's a 3-dimensional figure because it's a box. If I break it up and flatten it out, it becomes a net. And as you can see, we have the 2 bases, which are still red. The 2 bases, that's the top and the bottom. Okay? And then we have the 2 sides. The sides are going to be these 2 right here. Those are the 2 sides. And then we have the front and the back, which is the rest of the lateral faces. So you can see the 4 lateral faces there. Now recognize, those 4 lateral faces, when it's laid flat, create one large rectangle. They create one large rectangle. I just want you to recognize that. All right, so now we want to find the surface area. So they gave us this formula. They gave us this formula in the book. 2 times the length and the width plus 2 times the length and the height plus 2 times the width and the height. And that's okay. It always works. Some people call it confusing and some people don't. I've had teachers who teach the umbrella method with this, and we're not going to talk about that because I'm not a fan of the umbrella method. But as you can see from your elementary days, length, width, and height, our box, our original box, is labeled length, width, and height over here. And that's okay. But I'm going to show you now the big boy, the big girl school formula, which we call 2 times the area of the base plus the perimeter and height. So in other words, and once you identify the bases, in this particular case we called it the top and the bottom, we are going to multiply that by 2 because there's 2 of them, right? So we have 2. So capital B stands for area of the base. Okay? So area of the base, area of the 2-dimensional rectangular base. And if you look at your reference sheet that I gave you, down at the bottom of the front page where it talks about geometric solids, we are specifically talking here about a right prism. Now a right prism is also a rectangular prism. It's also a triangular prism. It's also all the prisms. So instead of having one separate surface area formula that represents only a rectangular prism, like this one does, this one only represents a rectangular prism. This one I'm showing you, 2 times the area of the base plus the perimeter and height, that represents all prisms that we're going to deal with. All right? So when we name the base, we name that shape, we got 2 times the area of that shape, of that base. And then we're going to add to that the perimeter of the base. So capital P, that stands for perimeter of the base. So if the bottom is the base or the top is a base, we would find the length around that. And recognize right here, I'm going to use yellow. Recognize the perimeter of the base is going to be represented in this big blue rectangle. So we have one side of the base right here, which coincides with that lateral face right below it. So this right here with 1 mark, that's it. So if I come to the base and I mark 2 on that side, that is represented by this length right here. And if I go to this side over here, I'm going to put 3 marks. Well, that is represented by this one way over here. And then this side right here, which I'm putting 4, that is this one right here. So the length around the base, the perimeter of the base, is also the base or the length of that large blue rectangle created in the net. So that's capital P, perimeter of the base. And then we're going to multiply that perimeter of the base times the height of the prism. And remember, the height of the prism is the distance between the bases. So right here, if I look, that distance right there between the two red bases is the height. So that's why it's the same over here, because that's going to be here, and that's going to be here, and that's going to be here. That's the height. And we know if I wanted to find the area of that large blue rectangle, I'd go base times height of that rectangle. Notice a lower b, because that lower b represents a distance, a length. Okay? But the capital B represents the area of that base. So, ladies and gentlemen, 2 times the area of the base plus the perimeter height. That is the formula we want to use all the time because it works for every single prism out there, which is, it doesn't matter what the shape of the base is, it's considered to be a right prism. All right? We spent a little bit of time on this. Our next video, we're going to start doing some examples. So hopefully I've added a little bit and you have a real good understanding of now a prism and specifically a rectangular prism. We're going to complete our first quick write right here. And that is, I'm asking you to, once again, write the formula for the surface area of a rectangular prism. Please write the one that I showed you. Not the one that only works for a rectangular prism, but the one that works for all prisms. In other words, I'm going to help you out. I want 2 times area of the base plus perimeter and the height for the surface area of this rectangular prism. And I want you to identify, what does S stand for? What does capital B stand for? What does capital P stand for? And what does H stand for? I want to know what they all mean. Ladies and gentlemen, I'm sorry it took a little time, but hopefully we have a better understanding of prisms. And now we're going to get busy in our next video with some examples. I'll see you.